Take out, please, your homework, I believe it was 17C.
It's due tomorrow.
Oh, that's right, tomorrow, correct. Any questions on it so far? Excuse me, face front. A lot of chaos going on here. Thank you. I realize the schedule is different when you're singing mass, and by the way, I think you did a good job. But, that being said, last time. 17C, I want to poke through one or two questions you might have, so you don't have to just sit and suffer. Questions? This is on page 670, I think. Mary Kate. 8A and B. I'll do 8A. 672. Oh my goodness, what is that? I guess that is 672.
That doesn't make any sense.
It does.
That's gotta be a typo.
Yeah.
There's no way.
Yeah.
God, come on, we should go up and
That's
find
not even
it.
going up.
It's arithmetic.
It's like we're going down.
Why is it?
It is, tell you what, 8A, I didn't even see that.
How's that even possible?
That's impossible.
That's NA.
Just scratch out 8A.
You're not supposed to say arithmetic.
Yeah, just forget about that one. I don't know what they were thinking, but that's not.
Bella gave it to Johan.
Good catch. What's that?
Can you do it even?
What's
B.
your problem, Bella?
Yeah.
What the heck?
You liars.
What the heck?
There's still some
Hey, you did.
noise that needs to be squelched. And it stopped. Okay. Number 8B, 8 blank 1827. What? Whoa, whoa, 27, hold on. Can somebody tell me what kind of sequence this is supposed to be? Good.
No, geometric.
Should be geometric, at least it doesn't specify, but they did have this in the geometric sequence category. So how do you do it? Let's just double check and see if it could possibly be arithmetic. What did they add going from here to here? Yeah, 9. Could they have done that here? No. I mean, 8 plus 9 is 17, but then, oops. So it's not plus 9 plus 9 plus 9. So obviously it's not arithmetic. Yeah,
Can I solve it?
try it.
27 divided by 18.
Ah, good. If you think it's geometric, how do you find R? The next term divided by the previous term. You can take any two you want. I wouldn't do this because there's no number there. But 27 over 18 should work. Does that reduce?
Yes.
What is it?
It is 3 over 2.
3 over 2. Theoretically, we're multiplying by 3 over 2 over and over and over. Let's see what happens. What's 8 times 3 over 2? Oh, math people. Ledger, good.
4, sorry. Here, can you do 8 over 1, please?
Sure.
And then the 8 and 2 cancel.
Okay, down to what?
1 and 4.
Okay, so what's your answer?
12.
12. Now, I gotta make sure it works for the next jump. That would be a nice one for here, but if it's the wrong number, I don't wanna write it. Cece, take over. What's 12 times 3 halves?
36 over 2, which is
Yep.
2,
36 over 2 is what?
13 over, or no.
This will cancel down to save, but that helps.
Yeah, yes. And then
It's,
it's 18.
it's 18. In other words, it does work.
So,
And we know this works because that's where we get it from. So the missing number is 12. Does that make sense? Yeah, to find a missing arithmetic, you take the next term minus the previous term. So you're adding over and over. To get a geometric jump, you take the next term divided by the previous term. Because you're multiplying, so you divide to undo it. Alright, you have time for one more. Yeah.
9E.
9E. Write a formula for the nth term. 2 radical 6, 12, blank. What are they doing? Yeah. They're multiplying by radical 6. Now, we can get the next term, but they also want a formula. We'll do that in a second. First of all, can somebody tell me A1? Don't work too hard. Good. It's 2. It's the very first term. So the second term is 2 radical 6. Third term is 12. So I want to know eventually a sub n. Look in your notes and tell me the formula for a sub n for geometric. Susan.
A sub n equals A times R.
There's some A1.
A1.
A1 times
R.
R to the
N minus 1.
to the n minus 1 power. Correct. So if you can find the first term, and you can find the number of terms they are, should be able to do it. Can somebody actually give me the formula at this point? Go. Times radical 6 to the, exactly. That's the formula for a sub n. Did they ask you for the missing number or no? Oh, they didn't either? Well, that's nice. Ta-da. 2 times radical 6 to the n minus 1 power. Yeah.
Where's the R stand for?
R stands for the common ratio, like what you're multiplying by over and over and over. In this case, radical 6. Yeah, I should have written that down here, sorry. Does that make sense? Alright, quick question? Maybe? 2D. Number 2D. Oh, do the top and bottom separately. Just remember, the first term is 1, n equals 1. How do you get 0 if you start with n equals 1? Yeah. Yeah. So what would the formula be on the top of the fraction? Yeah. N minus 1. How about on the bottom? How do you get 2 if you start from n equals 1? Yeah. Exactly. The top is n minus 1. The bottom is n plus 1. So a sub n equals n minus 1 over n plus 1. So you can treat them as completely separate. Because they're not, it's not arithmetic, they're not adding the same thing over, they're not geometric, so you can find whatever formula works. Okay. So they're both adding 1, but here's how I say it. N equals 1, n equals 2, n equals 3, n equals 4, n equals 5. Basically, here's A1, A2, A3, A4, A5. And then blah, 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 if you just have n. This was 0 over 2, 1 over 3, 2 over 4, 3 over 5, 4 over 6. I don't know if we're looking for it. Oh, they did. Start with n equals 1. So a sub n, you have to use the number here in order to produce the top number and the bottom numbers. You're right that they're adding 1 each time, but you notice n is counting up by 1 each time? We can use that back. Actually, Mary Kay, do this for me. Start with n equals 2. I'm just picking it at random. Start with 2. How would you go down to 1? Right. So take your n and subtract 1. How do you get to a 3? Add 1. Does that formula work for every single one of these? Like, try 5. It does. If it works for all the terms, you're dead. That's the formula we want. Yeah. Oh, yeah. That's kind of spam. Thank you. All right. Everybody good? All right. Put that on ice. We're going to check that off tomorrow. And I am going to, what was I saying about 7A? I think I'm just going to give credit on that, but since I want to reward people who did hard work on this, if you want to hand in 7A, if it's all correct, I will treat it as +1 extra credit. It's up to you. Otherwise, you can just take the free credit and run. Draw on the credit.
All corrected by like it's already 13.
I didn't hear you.
For when you said all corrected, does that you have to have the answers to it too?
Yes. Yeah, for that. So, okay. We're not doing any more questions on this one right now. Right. We should have time to work today. We have new notes, but they're not incredibly long. Check out your notes, please. Last topic of the chapter. I gave you a taste of it yesterday, and I gave you the formula, but today we actually play with it. Infinite sums. So today's topic is infinite sums. And just look back in your notes. Make sure you have all of the formulas. Let me do it one last time. So a sub n, s sub n, and s. By the way, s, another name for s is s infinity. In plain English, a sub n means the nth term. Like a sub 5 is the 5th term. A sub 10 is the 10th term. S sub n is the, what we call the nth sum, where you add out the first n terms. So S sub 5, what does that mean? S sub 5 means you add up the first 5 terms. S sub 20 means you add up the first 20 terms, and so on. Okay? Just plain old S, or S infinity, means you add up all terms forever. And normally you'd figure that'd be pointless because you'd always get infinity. But yesterday we found out that was not always true. So here's the chart I'd like you to know. There are two different types of sequences. Arithmetic, right? And geometric. There's no general formula for a non-arithmetic, non-geometric, for ones that are neither. You just have to get those by hand. A sub n for arithmetic, can you tell me? A sub n is equal to what? For arithmetic, go.
A1
A1
plus B,
plus D parentheses,
not n minus 1.
good. Plus D parentheses n minus 1. Okay. Also, reminder, since this is a fairly formula-rich chapter, I am allowing a 3x5 note card in the test. One side, you can write as small as you like, but I would strongly advise you have these formulas and maybe a few examples. Can somebody give me the formula for S sub n, sometimes called Karl Gauss's formula for arithmetic? Let me see. Elijah. Do you have your notes?
I don't, they're at home,
Okay.
because I was doing work.
Okay. So, do you remember the nth sum?
I had not memorized.
Okay. The Karl Gauss's formula, remember you add up the numbers from 1 to 100? How did he do that?
The first and the last.
Correct. First and last term and did what with them?
Oh, this is A1 over N.
Sort of. I mean, let's just say I want to add up all the numbers from 1 to 100. You can do 1 plus 2 plus 3 plus 4 and it gets really hard. What was his trick again?
He took the first and the last.
And did what with them?
Subtracted?
Easier.
Divide.
What are they trying to do?
Find them all together.
Add them all together.
Okay.
So they added the first and last. What did you get when you add the first and last?
101.
101. Try the next pair. What's 2 plus 99?
101. And everything else is 101.
Right. In other words, he added the first and last. How many pairs are you going to get that way? How many pairs of numbers? Like from 1 to 100?
Is it 50?
50. How do you get that?
Took the half of 100.
Right. If n is the number of terms, like this is a sub n, or n is 100, here's the formula. N over 2, which is the number of terms cut in half, and then first term plus the last term. That's the formula. Okay. Can somebody tell me the infinite sum of arithmetic? Go on.
Not applicable.
What's that?
Not,
Not applicable. There is no formula for it. Geometric. Can somebody give me the nth term formula? There.
A
Leslie.
sub n equals A1,
What?
times R to the n minus 1.
Correct. A sub 1 times r to the n minus 1 power. A1 is the first term. R is the common ratio, that's what you're multiplying by over and over. And n is how many terms. So if you want the 10th term, you would do the to the 10 minus 1 power. It was introduced yesterday. Can somebody in their notes tell me the sum, the nth sum for geometric? Anybody have it? Go right ahead. So S sub n, A sub 1, and it'll be a fraction. Good. Good. 1 minus r to the nth over 1 minus r. Do not do r to the nth on the bottom, only on top. They look almost identical, 1 minus r, 1 minus r. The top is a little different, it's r to the nth, and they do not cancel. Please do not cancel the 1s, please do not cancel the r's. Can somebody tell me why not? Yeah. They're subtracting. Adding and subtracting do not allow you to cancel a single term. So, questions? Yeah, okay. Definitely. That's the whole point of the test. We're going to do that today. I'm sorry? Yeah. S sub n is like the 10, let's say S10. That's like adding up the first 10 terms. And then you just plug in 10 here. And then whatever you're multiplying by, plug in here. And then here's your first term. You just plug, 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 and theoretically you're done. You might have to simplify the fraction might reduce. I'll show you an example in a second. It's hard to do it in your head. Can somebody give me the infinite sum for geometric in your notes? It's quite similar to this, only easier. Go on.
S equals A1,
Yep.
and then
In parentheses fraction.
1 over 1 minus n.
That's it. The top is, it's almost identical to the previous formula, but the top is easier. The minus r to the n gets dropped. And that's all you need to do. I need to add something new today. Here, put an arrow to this bottom. The S of n, it only works if the absolute value of r is less than 1. In other words, r is a small fraction. If you're multiplying by something over and over and over again, and you're hoping to add up an infinite number of terms, r had better be pretty small, like 1/2 or 2/3, something less than 1. You can do negatives, but it has to be bigger than -1. In other words, if you take the absolute value, that has to be less than 1, otherwise this will fail. Otherwise you just cannot do it. There is no infinite sum. It'll be infinity. Let's try a few of these and see what they look like. I'm going to try a geometric sequence. Okay, 256, 64, 16, 4, dot, dot, dot. Go ahead and write that down. Example. I'm going to ask you for several things. The very first thing I'm going to ask you for is it arithmetic, geometric, or neither? And then I'm gonna ask you to prove your answer. Elijah,
Geometric.
how do you know?
R is equal to 4.
You're on the right track.
It's dividing.
How do you divide by 4? You multiply by,
Multiplied by 3.
dividing is the same as multiplying by the, what's the reciprocal for?
Oh, 1 over 4.
Yes. And we're always multiplying for geometric. So you said it's geometric, you're correct. And the proof, R equals what? 1 over 4. 1/4. You're multiplying by a 4 over and over and over again. How did you get that 1/4? Yeah.
Well, 4 over 1. And the reciprocal is 1 over 4.
Where'd you get the 4 in the first place?
Oh, you divide, if 256 is divided by 4, and then you get 4.
Okay. Now, what's the trick for always finding R? This will always work if you do it correctly. Yeah.
Divide, like, the second term by the previous term.
Yeah. Divide the next term by the previous term. Pick any pair of terms that anyone should work, because they all have the same ratio. Pick the next term. You can do this one, it's nice and easy. This one is a little harder. I'm gonna just pick this one because it's nice and easy. You take the next term divided by the previous term, which reduces down to 1/4. Any of these pairs should work. 16 over 64 also gives you 1/4. 64 over 256 isn't as easy to see, but it actually does reduce to 1/4. So be okay with that. Finding R and finding out that it's geometric. Second question. Can somebody give me the formula for A sub n? Cecil.
I have a question.
Yeah.
So for S sub n,
Uh-huh.
how do you know what the
This
nth
one?
term is? Yeah.
Okay. S sub n, that's how, like you're at, if you want to add up the first 30 terms, that's S30.
Okay.
And then you have to find out if it's arithmetic or geometric and figure out which formula you need. A sub n, they basically want the nth term. Joe, help me out, get a formula for this. A1? Yes. By the way, let me just do the generic one. It's over here. A1 times R to the n minus 1. So go ahead, what was A1? 256 times what? 1 over 4 to the power of what? And you can't do much with this. You pretty much just copy and paste. N minus 1. Because I don't know what n is. Yeah. If they actually give us a number, we can plug it in. Like if you wanted A10, you do 256 times 1/4 to the 10 minus 1. And then actually figure out what that is. Does that make sense? Can somebody figure out A7? And I want a simplified answer. Did you go?
256
Uh-huh.
times 1/4
Okay.
to the power of 6.
To the 7 minus 1, better known as 6. Now this is going to be a little grotesque. 256 times, can anybody tell me how to raise a fraction to a power? And how to do that? Yeah. Okay, go.
Do you do it on top and bottom?
Do that on top and bottom. So it's going to be 1 to the 6th over 4 to the 6th. Now 4 to the 6th is kind of big. Question? Yeah, very bad. Let's see what we get. What's 1 to the 6th? It's 1. So it's 256 times 1 over, what is 4 to the 6th power? At this point, I also allow the use of a calculator. At this point, I would actually ask you to take them out. If you do not have one, you might want to scurry over there and grab one. Yeah.
1 over 4,096.
1 over 4,096, next. I want to talk through that with everybody once you have calculators in your hand. How do you get 4 to the power of 6? Go.
4 times 4 times 4 times 4.
That's 1. 6 times. There's another button in there, depending on the calculator. If you have a TI calculator, you'll see something that looks like this. This is the raised to the power key. It's called a caret. So if you had like, if you hit the number 4, then you hit that, then you hit 6, you should get 4,096. Sometimes, depending on your calculator, you might have something that looks like this.
It worked.
X to the Y power, or sometimes A to the B power. I've seen those. Does anybody not have any of those 3? Okay, yours with the graphing calculator would be this. It's on the right hand side of a halfway down. Any other ones? Yeah. Oh, okay. Oh, you don't have to. Oh, you don't have to key it off. Oh, I see. Yeah, this is, yeah. I would recommend you borrow one of mine. So, unless you want to do it by hand, which you can, do 4 times 4, and then take that times 4, and then that times 4, and then that times 4, and then that times. I'd recommend you borrow another calculator. Yeah. There's like basic calculator, scientific calculator, and graphing calculator. You need a scientific or a graphing calculator for this. Yeah, that works. That works. Perfect. Now, oh math people, reduce. Ever agree there's 256 over 1? So look up here so you know what I'm talking about. Everybody. This is 256 times 1 over 4,096. That'll give you 256 over 4,096. Tell me how to reduce that. There are several ways. Even if you have a calculator, you still have to know what to do. Any brilliant ideas? I do. 256 times 2 is 512. Yeah. 5, and that would be 1,280.
Where are you multiplying?
Yeah.
I want to know how many times 256 goes into 4,096.
Oh.
In other words, I want to reduce. I mean, I don't even know if it goes in evenly or not. If it does, then woohoo. Yeah. 16. So what does this reduce to? Notice the bigger number's on the bottom. 1 over 16. See how we did that?
No.
Don't put the number 16. The original number was less than 1. You can't magically become 16. Okay? 256 over 4,096, I want to know what goes into both of those. I mean, if this actually goes in evenly, that saves us a lot of work. You can do quick type 4,096 divided by 256 and see. It actually did work, by the way, 16 times. So these, you can shrink the top and bottom by 256. You get 1 over 16. That, by the way, is a 7. Questions? And now, what is S of 5? I'm not going to give you a huge one. S5 is probably not, I probably wouldn't go much bigger than that. But basically when I add up the first 5 terms, you could theoretically do this by hand, but I'd like you to do it with a formula, just in case I ask for S10 or something. Yeah.
S sub 5 equals 256
256,
times
and big fraction,
1 minus 1/4
to the
power of 5.
power of 5 over
1 minus 1/4.
1 minus 1/4. Let me clear this up over here. It's a pain in the neck to type in. I'll be the first to admit that. It looks like this. By the way, it depends on your calculator. If you have a basic calculator, there's just 1 row. If you have a display calculator, there's 2 rows. If you have a graphing calculator, you've got 8 rows. Here's what it looks like even on a display calculator. How do you type all of this in? That's a bit of a pain, but math people, parentheses inside parentheses inside parentheses, what do you do first?
Outer bracket.
The parentheses that are where? The furthest in. Here, there's sort of anytime you have a fraction, there's invisible parentheses. I would do this one first. 1/4 to the 5th power. What is that? I'm going to rewrite this. S to the 5th equals, mark it down, is 256 times 1 minus 1/4 to the 5th power over 1 minus 1/4. Now what? And I will probably, on a test, when I do a sum, these get really gross really fast. This is one of the rare times I will accept a decimal approximation. So I would be okay in this particular case with giving me a decimal. If you do a fraction, great, as long as it's the right fraction. Yeah.
We do 1/4 to the power of 5.
Yeah, 1/4 to the power of 5. How do you do that?
Do it on top and bottom.
Yeah, 1 to the 5th over 4 to the 5th. And you know what 4 to the 5th is?
10/24.
Yeah, 1024. 1 over 1024. Let me rewrite this. 256, 1 minus 1 over 1024 over 1 minus 1/4. What do you do next? By the way, I'm probably only going to give you one problem like this because it takes a while. I'm not going to do 10 of these. How do you do 1 minus 1024? Yeah. Right, we need a common denominator. Like what? 1024. Can anybody tell me how to do that? It's actually pretty quick. Exactly. 1024 over 1024. Let me stop. Did everybody see what we just did?
Yes.
Common denominator. So what's 1024 minus 1? 1023. Recopy. By the way, you may learn from previous tests, recopying is your friend. Don't try to do lots of steps in your head. That usually is where problems start showing up. This is 1023 over 1024. And somebody did that same trick on the bottom. 11.
4 over 4 minus 4 over 4.
Correct. So what is that?
3 over 4.
3 over 4.
Number doesn't do that. 1.
Maybe.
1 doesn't.
I see a fraction, yeah.
Can you multiply by the reciprocal?
Yeah, dividing by a fraction, multiplying by the reciprocal. Recopy is your friend. 1023 over 1024 times what? 4 over 3. Can anybody reduce anything? Question or answer? Okay. 1023 by what? Yes, you can. By how, what did it make? How many times does 3 go into 1023? 341? Nice. Good catch, by the way. When you add up the numbers and they divide by 3, so the 3 goes in. Anything else reduced?
Yes.
Like what? Yeah. The 4 and the 1024 down to what? 2, really?
Yes.
And then this is what? 1. Let me rewrite this. 256 times 341 over 256. Let me see the trick. Go.
You cancel the 256. The answer is 1.
341 is your answer.
Wow.
Is that gonna be on the test?
Maybe.
Yes.
You don't really give you.
You will not be much worse than that.
We have to do
Let's put that one.
Understood.
That was a relatively nice answer.
Wait,
So don't get too used to that. Let me see how we got that. The main battle was simplifying. You ever look up here? Everybody? Not only looking up here with mouse in neutral, so I know you're listening. If you write this, I will give you at least half credit. Because that is the answer. But I want you to simplify it down. Okay? But definitely write this. If you do not write that, you're probably going to lose most of your points if the answer's not right. Write this. So at least I'll know you're using the formula correctly. I might even give you 6 out of 10 for that. Who knows? Clear? Now, is it possible to add an infinite number of these terms. In other words, if it goes forever, can somebody give me S infinity? Otherwise known as S. Sometimes you can, sometimes you can't. Here's the condition. Find R and see if its absolute value is small. Less than 1, in other words. Susie.
It would be S equals 256 times 1 over 1 minus 1.
Okay, if it works,
Yeah.
it'll be 256 times 1 over 1 minus what?
1.
1/4. Will it work? Are we authorized to use this? Because by the way, if it's illegal, you'll still get an answer. It'll just be wrong.
No.
So be careful. It's not something where you'll just immediately get no solution. It will give you a wrong answer if you don't pay attention if it's legal.
It's not legal.
Let's check. Can you tell me what R is? 1/4. What's the absolute value of R? 1/4. Is that less than 1? Clear. It's less than 1, therefore, you're authorized to do it. Let's see if it actually works. So, recopy. Can you try that trick of it? By the way, the top is a lot easier. What's the bottom? Yeah,
3 over 4.
3/4. Tell me how to do this. Dividing by 3/4 is
That is
multiplying by the
reciprocal.
reciprocal. Go for it. By the way, I'll tell you right now, this is not reduced. Just multiply. What do you get? It'll be a fraction. And leave it as an improper fraction. Don't do a mixed number thing. Because it's super annoying. Yeah. 1024 over
3.
You got it. If you added up an infinite number of terms on this thing, you get 1024 over 3. Guaranteed. That's how you do all these formulas. Does that make sense? If you had been multiplying by something that was big, multiplying by 2 over and over and over again, there is no infinite sum that's legal. It fails the task. The only time you can do an infinite sum is if R, absolute value of R, is small, is less than 1. Okay, open your books, please. I want to do a little surgery on 17B. It is, I'm actually going to make it due Friday, because I'm going to read off answers, I just want to be able to show the work. Friday's the test, and I will also check off any homework that I haven't checked off yet on Friday. I want to give people a few extra days on this.
Wait, what?
All right. 17D, where it starts on page 678, the problem. Ladies, listening. CC, Don, listening. The problems are following. Scratch off number 1. I do want number 2. I do want 4. I do want 5. I didn't do 6 anyway, that's good. 6 is dumb. I mean, usual. Number 7. I do want number 7. Scratch off number 8, all of it. And I'd like you to try number 10. So 2, 4, 5, 7, 10 is what remains of the homework for 17B. 2, 4, 5, 7, 10. And that's it. Okay. The rest of the hour is yours. Go ahead and plug away at that. Let me know if you get stuck. Otherwise, go to it.
Do you want me to turn this off?
Yeah.
Do you want me to turn this off?
Yes, please.